Hello guys, welcome to another lecture. Today we're going to talk about relationships or associations between two variables. We're going to learn how to use what we call correlation coefficient to measure the relationship between two numerical variables. So our objectives today will be to compute the correlation coefficient using TI-84 plus and of course interpret the correlation coefficient. But before we go ahead to do that, we're going to look at some important information about correlation. When we compute the correlation coefficient, the values can range from -1 to 1. That means that the correlation coefficient value cannot be less than -1 and cannot be more than +1. So the values can be negative or positive. A negative value indicates that there is a negative association between the two variables. That means that as one variable increases, the other decreases. A positive value indicates a positive association between the two variables, which means that as one increases, the other also increases. So in looking at the correlation coefficient, we look at the magnitude, which is the size. The number tells us the size of the relationship, and then the sign tells us the direction of the relationship, positive or negative. So as an example, the amount of gas you use in your car or you have in your car determines the amount of distance you can travel. So as the amount of gas increases, the distance you have to travel will increase. So this is an example of positive relationship. The second example, talking about distance traveled and the amount of gas left in your car, shows a negative relationship because as the distance increases, the amount of gas left in your car will decrease. So finally, in correlation, we don't talk about causation. In other words, we don't say that one causes the other to happen. Okay, so when we compute R, we can have a weak correlation. Any value that's close to 0 is considered weak. The middle numbers 0.4, 0.5 can be considered moderate, and of course when the value is close to 1 or -1, we say that the relationship is strong. So we are going to go straight to our TI-84 plus and compute the correlation coefficient values for two of the variables, two at a time. So first we're going to find the relationship between weight and math test scores. Weight we're going to enter in L1 and math test scores in L2. Of course, IQ will be in L3. So I am going to turn my calculator on. The first thing I will do so that we can see the correlation coefficient values is to go to diagnostic or go to catalog and turn diagnostic on. So to get to catalog, you will go to do second 0, that's catalog, and then you are going to scroll down to find diagnostic on somewhere there. So when you see diagnostic on, you enter, and once you enter, it means that you can now see the correlation coefficient value when you do linear regression. So here it is. I'm going to enter and enter again. Make sure you see done before you can proceed. So having done this, now we are going to go to start. Remember, we go to start to enter anything from a table. So go to start and we enter. You can see that the numbers are already entered. So to save time, L1 has values for weight, L2 math test scores, and L3 IQ. So we are going to quit second mode, and to compute the correlation coefficient, we'll go to start again and now go to calc and select number 4. And you can see X list has weight L1, Y list should have the second variable. In this case is math test scores, which is L2. So I'm going to change this to L2 second 2. Okay, so that's all we need. So we are going to go to calculate, and you can see right there the last output is what we need. That's the correlation coefficient, 0.6285. So for weight and math test scores, the correlation is 0.6285. You can choose any number of depending on what you want to do. I have chosen 4 decimal places. So what does it mean? It means that there is a positive linear association or relationship between weight and math test scores. Okay, what do we interpret this to mean? It means that as weight increases, math scores increase. Okay, that's interpretation. So this is a positive relationship. We can consider this as moderate because of the value 0.6. So we're going to go next to look at the relationship between math and weight and IQ, weight in L1 and IQ in L3. So we'll go back to start and go to calc and select number 4 again. But because we are looking at weight and IQ, so we are talking about L1 and L3. So Y list will be L3. So I'm going to change that to L3, second 3. Okay, everything is okay. So we calculate. So now we have a negative relationship between weight and IQ. So as your weight increases, IQ decreases. Well, we've got to do something about our weight to have a high IQ. So weight and IQ, the value is negative 0.97. Let me just stop at 2 decimal places. The relationship, there is a strong because it's closer to -1, strong negative linear, let's put linear relationship between weight and IQ. Okay, and then interpretation, as weight increases, IQ decreases because it's a linear negative association. As one increases, the other decreases. So that is how we compute correlation coefficient. You turn the diagnostic on first and then compute your linear regression, which will include R as an output. So I want you to try this, what I have done, to see if you're going to get the same results, and also practice with this. We'll have X 2, 4, 8, 5, 8, 12, and Y 100, 220, and the rest. I want you to establish the relationship between X and Y. All right, thank you for listening. See you next time.